Hello, and thanks for joining me on Cooking with a Scientist. Today we're going to take another recipe from the Carbohydrate Metabolism Cookbook. Here with me I have the recipe for the electron transport chain. Now we start with 10 NADH plus H pluses and 2 FADH2s, which we originally produced from glycolysis and the Krebs cycle. So this represents an NADH plus H plus, and this represents a FADH2. Now our first step is to place all of the ingredients here on the cutting board, which I've already done. And the cutting board represents the cristae of the mitochondria. This is where the electron transport chain actually takes place. Now we will transport the NADH plus H pluses into the first small kitchen appliance, which represents a cofactor. Now a cofactor is a protein attached to a metal. Now we will activate the first cofactor, which actually separates the hydrogens from the NADH plus H plus. So now you're left with all the hydrogens in the first cofactor. And we're going to further separate this compound. We're actually going to separate the hydrogens themselves into protons and electrons. So these represent electrons. The electrons are going to be scooped up by this spoon, which represents the respiratory enzyme complex, and they're going to be dropped off into the next system. Whereas the protons are going to be dropped off into the intermembrane space. So all the protons are now in the intermembrane space just outside, and all the electrons are in the next cofactor. Now, the next cofactor actually accepts the FADH2s. They come up to the cofactor. It's accepted. The cofactor is then activated. Oh! I think I lost a piece, but that's cool. And the hydrogens are separated from the FADH2s. And then those hydrogens are further separated into their electrons and protons. Remember, in the cofactor, it separates them, the electrons and protons. The electrons are going to eventually just be turned into water. Just returned into water. And the protons go back into the intermembrane space. Now, you have a bunch of protons in the intermembrane space. And they want to come back into down the gradient. And when they do that, they're coming back down the gradient. What they actually do is they attach an extra phosphate group onto an ADP to form adenosine triphosphate. So now it has 3 phosphate groups, and it successfully formed an ATP. And this recipe actually makes 34 ATPs, around 34, and 6 waters from the electrons per glucose molecule. So thank you for joining me and learning about the electron transport chain.